Hello, welcome to the homework. So what we're going to be doing is we're going to be practicing with our new definitions of trig functions. So in your notebook, this is section 4.3, and you guys can write down the directions. You can find the values of all 6 trig functions. Feel free to abbreviate, and we're going to simplify our answers. So here's our first one. Go ahead and draw this triangle in your notebook. This side has a length of 2, this side has a length of 3, and I've selected this for our angle theta. This is the right angle. Theta has to be an acute angle. It can't be the right angle. And if we want to evaluate all 6 trig functions, then what we want to do is we want to remember SOHCAHTOA to start. And SOHCAHTOA reminds us that our trig functions are sine, cosine, and tangent. And then the reciprocals that we learned that are new, what I'm going to do is when I find all 6, I line them up in 2 columns. The reciprocal of sine is cosecant. I'm leaving space in case I have to simplify. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. You will want to eventually memorize that, but that'll come through just practice, through actually doing problems. You're just going to end up memorizing this kind of by accident. So in order to do this work, we have to look at our triangle and identify the opposite, the adjacent, and the hypotenuse. With respect to the given angle theta, 3 is the opposite side, 2 is the adjacent side. The opposite side is the side that's across from theta. The hypotenuse is the side that's across from the right angle, of course. And then the adjacent side is the one that's left over. It's one of the 2 sides that makes up the angle, but it's the one that's not the hypotenuse. So like I said in class, it's kind of wordy to describe it. So I usually find the opposite and hypotenuse first, and then the leftover one's the adjacent side. Before we can start doing all of our work here, we have to find the length of the third side. This is not a Pythagorean triple, so we're going to use the Pythagorean theorem. Okay, so this is not a special pairing of side lengths here. So what we're going to do is I'm going to go ahead and put hypotenuse squared. You can just put x squared or h squared, whatever you like. And when we solve for the hypotenuse, we're going to end up taking the square root of both sides. And when you take the square root of both sides, you usually put plus or minus. But since this is a length in a triangle, we're going to ignore the negative value anyway and just use the positive value, radical 13, for the hypotenuse. All right, let's go ahead and use SOHCAHTOA to get started. So of SOHCAHTOA means sine is defined as opposite over hypotenuse. So we're going to grab the opposite side and put it over the hypotenuse. And then we need to rationalize that denominator. So to rationalize the denominator, we want to multiply by radical 13 over radical 13. And that's going to give us 3 radical 13 over 13. I'm assuming that you remember that from your previous 2 years of math. If you are rusty on that skill, you can ask about it in class tomorrow, or you can schedule extra help if you like. Evidently, I didn't leave enough space for my work, so I'm going to move those over. All right, and that's the value of sine. What I'm going to do now is I'm going to find cosecant. There's no reason we can't continue to cosine and tangent, but since cosecant is the reciprocal of sine, we can just go ahead and flip sine. Now, be careful. You can flip this, but it would be smarter to flip this one, because check this out. If you flip this one, you're going to get radical 13 over 3, and you're finished. You have no simplifying to do. If you were to flip this one instead, it's not wrong. But look what happens when you use the reciprocal of this. You end up having to multiply by radical 13 over radical 13. And what happens is the numerator becomes 13 radical 13. The denominator becomes 3 times 13. The 13's reduced, and you're back to that same answer anyway. So why do all that extra work? What I say is flip smart. So you want to flip this one to get the reciprocal of cosecant instead of this one, just because it's less work for you. The other way to get cosecant, if you like, is to use the definition. Since sine and cosecant are reciprocals, if you read this backwards, since the definition of sine is opposite over hypotenuse, then the definition of cosecant is hypotenuse over opposite. So hypotenuse over opposite would be radical 13 over 3. So you have some options there. All right, cosine is next. Cosine's definition is adjacent over hypotenuse. So that's 2 over radical 13. If you can get to 2 radical 13 over 13 without showing the work, that's absolutely fine with me. If you would be more comfortable showing that you rationalize the denominator by multiplying by radical 13 over radical 13, then show that step. Either way is okay. For secant, we can flip cosine, but again, don't flip this one. Just flip this one over here. Or you can find that using the definition. Since cosine and secant are reciprocals, if cosine is adjacent over hypotenuse, if we run that backwards, the definition of secant is hypotenuse over adjacent. And right now, that kind of may make your brain hurt. But once you get used to who the reciprocal partners are, it becomes a very quick process for you. All right. And then finally, for tangent, we have opposite over adjacent from SOHCAHTOA. Opposite over adjacent, which is 3 over 2. We're just going to leave that. We typically leave it as an improper fraction. We don't make it a mixed number or decimal. And cotangent would be 2/3. All right. So once again, this type of problem, if you're looking at these answers and saying, okay, I can do that, but what's the point? The point is we're just practicing definitions. There's no real life application where you would want to find all values, 6 values of the 6 trig functions. We're just getting familiar with the definitions at this stage. All right. And these are going to be our next 2. So instead of doing all 6, because sometimes that's an awful lot of work, for this one, we're just going to find tangent. So go ahead and copy into your notes. For number 2, you can just write find tangent theta, draw yourself the triangle, indicate the right angle. This is the angle theta that's given. This side is 3, this side is 3 radical 5. So this side is the opposite because that's across from the angle theta. This is the hypotenuse because it's across from the right angle. And the adjacent side is unknown here. So in order to find tangent, since SOHCAHTOA, and you know what? I'm going to go up here and show you. Typically, what we usually do, what you're going to find you do, is just on the top of every page, you just write SOHCAHTOA. So you don't have to write that over and over and over again. Just throw it on the top of the page once and you're good to go. All right, but feel free to write it again. So if you wanted to write SOHCAHTOA again, that's absolutely fine. But from SOHCAHTOA, we know the definition of tangent is opposite over adjacent. And again, that's a definition. This I can't explain. All right, this you have to accept because it's the definition of tangent. So I have opposite, I don't have adjacent. So what we'll need is the Pythagorean theorem here. So if I do 3 squared plus, this time I'll use x, okay, for x, for the missing side, and then 3 radical 5 squared. Okay, so the hypotenuse squared, of course, always goes by itself in the Pythagorean theorem. So the unknown here is over here in the expression that's being added. So it's 3 radical 5 squared that goes by itself because that side is the hypotenuse. And now we simplify. What happens often here is people often think that this is going to be 15, but as it turns out, it's actually going to be 45. And that's because when you square 3 radical 5, notice that I put the parentheses, okay? Because without the parentheses, this would be different. This just means square radical 5. That's not what we're doing here. We want to take the entire length of the hypotenuse and square it. So when you square this, you're multiplying it by itself. So what happens is you end up squaring the 3 and squaring the 5. Because if I use the commutative property here, you can see that I have 3 times 3 and 5 times 5. So that's where I got 45. And again, that's a really common mistake, especially when you're just beginning trig, because you may not have seen that in quite a while. All right, and then I move the 45 over to get 36. When I take the square root of both sides, we usually put a plus minus. We're just going to use the positive value because it's a side length. And finally, we can go ahead and find tangent. Opposite over adjacent for this one is 3 over 6, and it's just 1/2. So actually pretty nice answer at the end once you finally get your final answer. All right, and our last one for today. I kind of bumped into this one here. Let me cover that up a little bit so that it won't be in your way for focusing on number 3. Okay, for number 3, we're going to be finding secant. I switched things up on you. I made it beta instead of theta. So secant of beta, your right triangle that you want to draw on your notebook, this is the right angle. This is the angle I've selected for us for beta. This side is 15 and this side is 25. Our job is to find secant. Okay, now remember SOHCAHTOA. Do you know who secant is the reciprocal of? Is it the reciprocal of sine or cosine or tangent? Secant is the reciprocal of cosine. All right. So secant's definition is going to just go backwards here. Instead of adjacent over hypotenuse, secant's definition is hypotenuse over adjacent. And if you look at what we have, hey, look at that. This is hypotenuse, and this is the adjacent side. So we actually don't need to find the third side. We can go ahead and find the secant of beta. That's 25 over 15, and that's going to reduce to 5/3. So we're actually finished with that problem pretty quickly. Just to mention, if anyone did notice, this is actually a Pythagorean triple. You have 15 here and 25 here. That's a 3-to-5 ratio. So it's a 3, 4, 5 multiple. So this side, if you were to figure out this side here, because this is, let's see, 15 and 25. So we multiply by 5, we multiply by 5. This actually is going to come out to 20 because it's a multiple of a 3, 4, 5. Let me write that more clearly. So 15 and this is 25. Since that ratio is 3-to-5, and this is the hypotenuse, we can multiply by 5, multiply by 5. And if we multiply that middle length by 5, we get another Pythagorean triple of 15, 20, 25. So again, we didn't need the opposite side for this one, but if we did need it, there's a Pythagorean triple there, and that's a nice shortcut for you. But there's no harm in using the Pythagorean theorem. These would be larger numbers, so it might be a little uncomfortable. What's that, 625? And then you get x squared equals 400, so x equals 20. So you get kind of larger numbers. It's a little uncomfortable, but definitely nothing wrong with doing Pythagorean theorem here to get that third side if you needed it. We did not need it in this case. All right, thanks for watching. We'll pick up right from here next time we meet.